Now we are going to discuss projectile from a moving reference frame. To analyze this, we consider a physical situation. Like say we are having a cart moving in a horizontal direction on ground with a speed v. On the cart there is a boy who throws a ball with a speed u relative to this cart at an angle alpha from the horizontal. We can simply state that this particle or the ball will follow projectile motion, but this motion cannot be analyzed with the relations we have studied earlier. Here we can simply state the speed with which the ball was thrown. It was relative to cart. When the boy was holding the ball was itself having a velocity v which was there in the cart. So when ball is thrown at an angle alpha with the horizontal component of this ball's velocity can be written as u cos alpha plus v, because v was already there in the ball and u cos alpha is provided by the boy. And in vertical direction we can state the ball was imparted with the velocity u sin alpha, and there was not any other velocity in the ball because cart was moving horizontally, not vertically. So here we can say initial velocity components of ball's motion, if we talk, we can simply state in x direction it was u cos alpha plus v, and in y direction it was u sin alpha. Now during this projectile motion, the ball continues to move with the constant velocity u cos alpha plus v, that is ux, and in y direction, if it was initially having a velocity u sin alpha, it was retarded by g. So we can simply state in this motion, throughout the motion, the total time of flight can be calculated by its vertical direction, and that time of flight can be used to calculate the range of projectile. Here if we simply calculate the time of flight, always remember the time of flight calculation can be done by y directional motion, that is free fall. In this situation, particle was thrown up with the speed u sin alpha and it was retarded by g. So time it will take to reach the top is u sin alpha by g, and same time it will take in coming down. So time of flight can be simply written as twice of uy by g. That will be, in this case it is 2u sin alpha by g, that remains same as that of the normal projectile. Now if we wish to calculate the horizontal range of projectile, then in such cases horizontal range can be simply written as velocity in x direction multiplied by time of flight. So your horizontal velocity which it was initially having can be written as u cos alpha plus v, and is multiplied by the time of flight, that is 2u sin alpha by g. This is the way how we calculate the range of projectile. We'll also see some examples based on this. Let's take up an example where we are given that a boy in an automobile throws a ball at 40 meters per second at an angle 45 degree from horizontal as shown. Here we are shown that an automobile is moving at 10 meters per second through which a boy is throwing a ball at 40 meters per second. It is given that just after throw the boy jumps and starts running in same direction to catch the ball. He jumps off and running in the same direction. Here we can state that as soon as he throws the ball, the ball will start following the projectile motion, and the boy needs to reach this position where he will be able to catch the ball. At this point somewhere you can say the boy will be able to catch the ball. We are required to find the speed at which boy should run to catch the ball, and we are also required to find the time and position at which he will catch the ball. Now in this situation, if we just have a look, when the ball is thrown at 40 meters per second, the horizontal velocity of ball ux can be written as 40 cos 45. That will be 40 by root 2, it is 20 root 2 meters per second. Plus the ball will already be having the velocity of automobile, so this will be 20 root 2 plus 10 meters per second. This is the net horizontal velocity of ball with respect to ground with which the ball is moving forward. So when the boy jumps off to catch the ball has to move with the same speed so that the horizontal distance covered by the ball and boy should be same at the same time. So we can simply state this is the velocity of boy to catch the ball. So this should be the answer to the first part where it was asking find the speed at which boy should run to catch the ball. Boy should run with the same horizontal speed with which the ball would be moving so that he'll be able to travel the same distance in horizontal direction which was covered by the ball in the same time. And if we are required to find the time, certainly we need to analyze it by the y direction motion, where if we talk about the velocity of ball, it can be written as 40 sine 45. Again, it is 20 root 2 meters per second, with which the ball is thrown up. It will first move up and then it will come down. So time of flight of ball can be easily calculated by using the direct relation twice of uy by g. We just calculated, it will be 2 into 20 root 2 by 10. So this is giving us 4 root 2 second. So this is the answer to our second part of question. The time at which the ball will be caught, that will be 4 root 2 seconds. This is the time at which ball will be caught by the boy. And it is also asking the position at which he will be able to catch the ball. Boy is running at this much of a speed. So in 4 root 2 seconds, the distance it will cover or the range of projectile that can be simply given as this range r, the total distance which it has covered can be simply given as velocity in x direction multiplied by time of flight. This will be 20 root 2 plus 10 multiplied by 4 root 2. So the total distance we can see it will be 160 plus 40 root 2 meter. This is the answer where the boy will be able to catch the ball.